In this crash course, you will learn about one of the youngest programming languages that is becoming very popular in the cloud engineering world, which is Go, or also commonly known as Golang. You will learn the most essential concepts and syntax of Go while building an actual application throughout the entire tutorial. So let's see a detailed overview of what we will learn. Before diving into the syntax, we will first understand why was Go even developed? Didn't we already have enough programming languages? So you will understand specific use cases of Go and how it differs from other programming languages. Then we will set up our local development environment and see how the basic structure of a Go file looks like. Then, as we start writing our simple to-do list application, you will learn the core concepts and syntax like some common data types such as strings, integers, arrays, and slices. You will also learn about variables and variable scopes, about formatted output. We will learn about loops and why they're needed, as well as how to encapsulate logic in functions. And finally, we will make our simple Go application accessible for HTTP clients. So we will learn how to start a simple web server in Go and how to handle user requests to our Go web application. So we're going to learn quite a lot in this crash course, and I hope you're already excited to get started. Also note that all the code in each demo section is going to be available in the Git repository, which we will link in the video description, so you can follow along easily. Now, we have put a lot of effort in creating this course, so if by the end of this video you think it was valuable for you, please share it with one colleague or friend who you think will find this course as useful as you did. And also be sure to check out our website on techworld.com to browse our online courses and complete DevOps educational program if you want to learn currently probably the most future-proof profession that will be very difficult to be replaced by AI. Now, if you're absolutely new to programming in general, you can also check out my Python course on YouTube, which is even more targeted to complete beginners in coding. And with that, let's get started. Go was created by Google in 2007 and open sourced in 2009. So it's a pretty young language. Now, whenever you hear about a new programming language, the first question you probably have is, why do we need yet another programming language? What is the purpose of it, or how is it better or different from other already existing languages? So before diving into the syntax, let's see what was the motivation behind creating the Go language. Well, the infrastructure where the applications were deployed changed a lot in the last few years. Multi-core processors became common, and also using cloud infrastructure with hundreds or thousands of servers with multiple processors to deploy applications became pretty universal. So infrastructure became much more scalable, dynamic, and had more capacity. However, most languages couldn't help in writing applications that would take advantage of these infrastructure improvements. So basically, you had applications that would just execute one task at a time in order. But with infrastructure improvements, it was possible to now write applications that would execute tasks in parallel, do multiple things at once, this way making the application faster and more user-friendly. A simple example is if you are using Google Drive, you may be uploading or downloading files and folders, but you can keep navigating back and forth in the UI. So downloading, uploading, and navigating the UI all happen in parallel. Or consider YouTube. You can be listening to this video, then scroll down to the comments, write a comment yourself, like the video, etc. So the application allows you to do multiple things at once without affecting any other task. And this is a concept of multi-threading. So each thread is basically processing one task, and you can have many of them running in parallel. And this makes applications fast, but may also cause some issues. For example, on Google Docs, many users can work on the same document at the same time. So when you have two users changing and adding stuff at the same time to the same document, this should work smoothly without one user overriding all the changes that another user is making. Another example where such issues may happen when things are processed in parallel is a booking system for buying tickets or booking a hotel, etc. Let's say again, two users are trying to book the last remaining ticket at the same time. Of course, this should work in a way that no double booking happens. And this concept is called concurrency and needs to be handled by developers in code. So they must write code that prevents any conflicts between the tasks when multiple tasks are running in parallel and updating the same data. And many languages do have features for implementing such applications. However, the code can get pretty complex and handling and preventing the concurrency issues can be pretty hard. And with complexity, of course, there is always a higher risk of human errors. And that's where the main purpose and difference of Go comes into the picture. So Go was designed exactly for that purpose, to make writing multi-threaded, concurrent applications that take advantage of the new performant infrastructure much easier. So logically enough, the main use case of Go, or what it's best used for, is writing applications that need to be very performant and will run on the modern, scaled, and distributed infrastructure with hundreds and thousands of servers, typically on a cloud platform. For developing Go, they wanted to take the simplicity of syntax of a more high-level language like Python and the speed and efficiency of a lower-level language like C++. So you will see the combination of these things in Go. And I have to note that Go is used on the server side or the backend side of the applications. And these types of applications can range from microservices and web applications to database services and so on. In fact, many cloud technologies or technologies that run on modern cloud environments are actually written in Go, like Docker, HashiCorp Vault, Kubernetes, CockroachDB, and so on. Now, on top of this main purpose of Go, Go actually has a lot of other advantages. One of them that I already mentioned is it has a very simple syntax which makes your code very maintainable, easy to read and extend. Another advantage is that Go applications can be built very fast. They are also very fast in startup and also when they're running. Plus, Go is very resource efficient, which means it uses few resources or it requires fewer resources like CPU and RAM to run. Go is also a compiled language and it compiles actually very quickly into a single binary and you can deploy it and run it on different platforms in a consistent way. So no matter which operating system or which environment you're using, you can take that same binary and basically use it across different platforms. So considering all these benefits of simplicity and speed and so on, Go is becoming more and more popular for writing simple automation applications and command line interface applications for DevOps and SRE tasks as well. So now that we know why Go was created and what differentiates it from other languages, let's jump right into learning the core concepts and syntax of Go. So the first thing we're going to do is we're going to download GoLand IDE. So let's search for it. And GoLand is actually an integrated development environment that is perfect for writing and working with Go applications. That's why we're using it in the course, because it comes with everything we need for developing in Go out of the box, which is especially important if you're a beginner because everything is just made much easier. But GoLand can actually be used for many other programming languages as well, like JavaScript, Typeform, Python applications. You can even write Terraform projects with it. So it's not just for Golang, but you can use it with many other different technologies as well. And it's also very useful for experienced engineers because they have built-in tools like code completion, auto-suggesting code, refactoring help, and basically just helps with coding much faster. So let's download it. Of course, based on your operating system, you're going to download the respective one. For me, it's going to be macOS installer. And once it's downloaded, double click and install it in the applications. So it's pretty easy actually. Let's launch our GoLand IDE. And we're going to see how to create our first Go project directly from the IDE. And this is the welcome window where we can create a new project. So if I click on new project, this will give us a location of that new project. And there is one thing we need to configure, which is the SDK. So SDK stands for Software Development Kit. And basically we need to download and install Go compiler on our local computer in order for the Go application that we write in this IDE to execute and to run. And conveniently, the GoLand IDE actually gives us a way to download that directly from internet instead of us going to the official website of Go and downloading it from there, which is also not very difficult, but I still think it's more convenient to just click a button and download it from here. So this will basically do the same as installing the Go compiler from their official website. So if I click on download, this will actually give me a selection of the last two versions. And this is the latest version, 1.23.1. And this is the location where it's going to be downloaded in and where the GoLand IDE will also find it. So I'm going to click OK. And now we can select this as the Go version of our project. And it's important to note that these are two separate things. So this is an integrated development environment where you can write your Go application, where you can structure it. If you have hundreds of different files in the program, you can organize those files so it helps you write the Go application. And once you have written the application, it has to run, right? You need to be able to execute and run that Go application locally on your machine. And that's where this Go compiler comes in. So we need both of them to write the application and to run the application. So this is configured right here, which means with the SDK, we're going to be able to use different Go packages and functionality while writing the code. So with this basic configuration, I'm going to create a new project. And as you see, it automatically created the structure for the Go project. It generated the main.go file and basically gave us some boilerplate hello world or hello and welcome program. I'm going to clean this up because we're going to write our program from scratch. And you can also see that Go root configuration that we just configured with the latest Go version right here in the project settings. So how do we start writing code in Go? Like printing a simple message to the console. Let's actually write print hello, Go world. However, this will not work. First of all, let's see the highlighting here, the red underline, which says package expected got print. So program doesn't know where this print is coming from. And this is the first concept I want to explain, which is everything in Go, similar to many other programming languages actually, is organized in packages. And when you install Go program, it actually comes with some built-in packages that you can use to print out messages, to write some logic. So it comes with lots of packages that let you write your application. And one of those packages is called FMT or format. And packages have functions that we can use for a certain behavior. So whenever we want to use a built-in Go function to print a text, get user input, and so on, we need to import it from one of the packages. So think of the packages as containers of various functionalities that Go gives you readily available for you to use when writing your applications. Now, how do we know which function is in which package? Well, you learn by heart actually for most used ones, or you can always look it up in documentation. For example, if you're building something that needs to use dates, maybe you want to integrate a calendar in your application, you look up dates in Go to see whether there is a built-in package that gives you different functions for handling dates, like, printing out today's date, do some calculations on dates, and so on. So if you look up on Go official docs, you will see that there is a built-in package called time, which has functionalities to work with dates. So in our case, we just want to print out a simple hello world message. So let's import the FMT package that has a function to print out those messages. And it's as simple as just saying import FMT, which is the package name. So we are telling Go, hey, I want to use functionality from this package in my Go file. So make this package and all its functions available within this file. And then from that package, we're going to use one of the functions called print to print out a message. Now, this still will not work because whenever we want to execute a function, we need the main starting point for execution. Because if you have multiple files in your Go project, you will need to provide the program executor basically a starting point to tell it which file has this main function that is going to be the starting point of the application, and everything else, all the other files basically in the project will be connected to that main function. So that's where the execution of the program will start. So basically we're telling the Go compiler, start executing the program from this specific line. And we're going to do that using what's called a main function. And this is a similar concept as in Java, because Java also has this main function that tells Java compiler, this is where the execution of this program starts. So right here, I'm going to create the function called main. And as you see in the GoLand IDE, you actually have this auto suggestion for syntax of how to write main function. And I'm just going to hit tab and it will automatically fill out the rest. And our print statement will actually just go inside that main function block. And again, let's use the indentation. Now there's one more thing we need to do for this program to work. So this main Go file here, just like any other Go file that you're going to create, needs to start with a package statement. And as you see here in the underline, it is actually warning us that it was expecting package declaration and it found import. So right here at the beginning, we're going to put all our code into a package by defining the name of the package. And again, it's auto suggesting us to call this one main, which is what we're going to use. And we're going to be naming this whole file or this package main. And this is actually mandatory, as you saw, because otherwise the program will not run. As I said, everything in Go is organized in packages, including your own files. So what we wrote here is basically the main structure of a Go program with the package name, which is mandatory, the main function, which is also mandatory and serves as an entry point to the program, and importing any Go built-in packages that we need in our main function. Now, this program is actually ready to be executed. And as you see right here, as soon as we fix this issue, the GoLand IDE actually automatically added this triangular run button that says run application. So here is a very convenient thing about an IDE like GoLand, whenever you are programming in whatever language, is that instead of downloading the programming language compiler locally on your operating system and then running it from a terminal, you basically have everything integrated in one UI. That's why it's called Integrated Development Environment. So we used GoLand to install Go compiler or to download and install it on our operating system. And we don't even have to go to the terminal. We can literally just directly run the program from here. And in the background, it will execute that Go command to run the application. So if I click here, run Go project, there you go, the program executed, and we have hello Go world printed out here. And you see that we have the same button right here. So for example, if I had hundreds of other Go files and I was anywhere in the application, I could just hit run anytime from anywhere in the project, and it will execute or run my application, because this button is only next to the main function, because as I said, that is the entry point of execution. That's why we can run the application directly from here. But if I had another function, with the same code, for example, it's not going to get this run button because it's not the main or the entry point function. Awesome. So our very basic application is running. Now, as I said, this run button in the background actually executes this Go command with the Go compiler that we downloaded through the GoLand. So we could also execute this application ourselves with Go command. So here in the IDE, I actually have the terminal, just like your operating system terminal, and I can access it very easily using this tab right here. And in that terminal window, it opens the session directly in my project. So for example, if I were using my own operating system, macOS terminal, then I would have to navigate to the Go project. And so on. Here, I can just use the terminal built in the IDE. I don't have to switch back and forth. And because we installed the SDK using the GoLand, we can actually use the Go commands directly in the terminal because it was installed on our OS. So if I do go run main.go, this should execute our program as well with hello Go world. And for clean formatting, we can actually add a new line at the end of our message using /n. So this will add a new line. And again, if I run the Go command, you will see the updated program. And the same way, we can just rerun the program like this. Awesome. So this was a basic setup to just get started with writing the Go application. We have everything prepared. The program is running. We can execute it as soon as we make changes. So now we're going to start writing our actual application, and we're going to learn lots of concepts while actually building something that is functional and it works in real life. So let's go ahead and do that. So now we're going to create a to-do list application, and we're going to learn all the concepts that I'm going to explain from now on in the context of an actual application, instead of coming up with some random examples that are not related to each other, so that you can learn and understand those concepts much easier. So first of all, I'm going to start by printing out welcome to our to-do list app. And the first improvement we're going to make is if I do a new line here, and if I do fmt, you have this function here, another function that's called println, which is print line. So basically what this does is it prints out whatever text we provide here, and it adds a new line at the end, instead of us having to add a new line character explicitly. So it kind of makes that small improvement. So if we use print line here, we actually don't need this \n. And let's print out a to-do item, which is watch Go crash course. That's your first to-do. And let's run this. And as you see, both are on new lines because we have used println. Now let's print another to-do. And let's say this is to watch Nana's Golang full course, which, by the way, I'm gonna link in this video if you want to learn even more concepts in a full course. And let's add a third one, and let's call this reward myself with a cheesecake. Because after watching all those Golang tutorials and doing them, you deserve a small treat. So those are your to-dos. Let's run them. We can rerun with this button here as well. And here is our welcome, and here are our items. So we're only using this one function and just providing some text. Now let's add some additional elements to this text to differentiate. For example, this is the welcome message, and let's decorate it a little bit with these pound characters. And we can do 1, 2, 3 here. Let's see how it looks. There you go. Looks better, right? And here's the first concept of Go programming language, which is the concept of data types. Generally, in programming languages, we have data types, and the basic ones are strings and numbers. And also in most programming languages, we need to explicitly tell the programming language what data type we are using. And the way to tell the programming language is the syntax. And the syntax for strings is always to enclose them in these quotes. So double quotes at the beginning and at the end tell the programming language everything that's within those quotes is a string. And string is basically any sequence of characters that you see on your keyboard. So if you look at your keyboard, you have all these letters, you have all the number characters on the top, you have the space, you have commas, you have these pound signs and exclamation marks, and so on. All of this enclosed within the quotes is string for Go programming language. Now, you will be asking, what about the numbers? Because I see numbers on my keyboard, how are they strings? Well, if we want Go language to interpret a value as a number, then we simply put a number without enclosing it within the quotes. And you see this syntax highlighting difference. Here we have the green color, so to say, for the string, and this is the number. And again, we can do the same for whatever other number. And if I print it out, you'll see the numbers printed just like text. So let's delete those. Now, let's for a second think about an actual to-do list application. Usually you have this flat list of all the items that you want to check off, and usually you can group them into groups or labels like private, work-related, or you can even add them dates, so you have a list view of everything that you want to do today, tomorrow, on Wednesday, and so on, right? So let's say this is a list of all the items. And somewhere down the line in the application, we have, let's say you create a group called tutorials and you add those two in that category. And maybe you have another label or group, and let's call it reward or rewards, self-reward basically. And you put this third item in there. And let's remove those numbers because now they're just listed in any order. So I'm going to run this again and let's see what we have. So we have list of all the to-dos and then tutorials and rewards. Now there are two things that you probably notice here. First of all is that we have this space within the editor, but we don't have a space right here. And that is a very important principle, which is a simple detail, but an interesting one, is that the editor and what we see here is for us, human programmers, to write the code in a way that it's easily readable for us. But if we want to tell the program to execute something, that we need to always explicitly tell it with commands. So if we want a new line, then we have to print a new line. So for example, right here, I would do this. Let's run it. And we have our new lines here. So it's also cleaner in the output, not just in our editor. So that's the first small detail. Now the second one is that you probably notice that we are repeating the same value twice. And if we had another group, for example, let's say you created another label and you call that my project. So you're working some startup project or whatever, and you need to learn different things for that specific project. And one of them is Go, so you want to watch the Golang full course for this project. So now you are repeating it even 3 times in your code. And usually this is just a simulation, but in actual programming an application, you're going to have hundreds of files, and these names may be just spread around across multiple files. So now let's see what happens if I change the name of this task. Let's say instead of watch Nana's Golang full course, we wanted to change this name to watch TechWorld with Nana Golang full course. And now we need to replace it here and replace it here because it is the same task. So the name should be updated everywhere. And let's say you saw some very compelling Instagram video of a tasty donut. So now you don't want a cheesecake anymore, you want a donut. So we're going to change our task name here and here as well. You see, whenever we have a value repeating multiple times in our code, and we need to make a change to that value, we need to think where is all the places in my code where this value is used, and then I have to fix the name everywhere. And second of all, you actually have to repeat the same value if you want to use it in multiple places. And that's exactly the use case for what's called variables in a programming language. So instead of typing out the value, the actual value in 100 different places, you take that value, the actual string value in this case, you give it some arbitrary name, which is the variable name, and then you reference the actual value by using that reference name anywhere in the code where you need the value. So right here, we're going to do what's called a variable declaration. So we're going to take this value. I'm going to do Command X to cut out the value, and I'm going to save this value in a variable. So I'm going to do var, and let's call this task1 equals. So now, whenever we need this actual value in all the different places, like here and here as well, instead of typing out this whole thing, we can basically just say task1, task1, task1. That's it. So now if I needed to actually change the value back to Nana's Golang full course, I just need to do it in one place. And these references that are spread around again across hundreds of Golang files will automatically be now referencing to the new updated value. And as you just saw, we can print the actual string values, the numbers, or we could print the reference to a variable that references the final value. And if I run this, there you go. We have the new value printed out everywhere. And here's a great thing about variable names. You can choose what you want to name a specific value. So, for example, instead of task1, if we want this to be more descriptive, we can say full Golang. And we're going to replace it everywhere. As you see, if you actually change the variable name, then you also need to change that everywhere that you are using that variable. And now we can repeat the same for all the other values. So we can take this one, and we can call this short Golang because it's a crash course. Right here. And reward dessert. And now we can just paste it everywhere that we're using this value. And as you see, the code also got cleaner because instead of having all these repeated text, we now simply have the references to the actual values that we can change anytime without affecting the rest of the code. So again, let's rerun and we should see everything is printed out the same way, but the code is cleaner and more maintainable. And that is the main usage of variables. And you can assign any value that you want to a variable. For example, you can say number of tutorials. You can save numbers as variables and reference that specific number wherever you want in the code. So for example, maybe you have a limit to how many items can be per category. So we can say max items in category or in group. And let's say we only allow maximum 20 items. So whenever we need this number, this actual number, because maybe we change it later, we can reference it using the same variable name. Now there's one more thing I want to show here, which is an alternative syntax for declaring variables, which actually is a newer and cleaner way of doing it, which is we don't need the var keyword. And right here, we use colon equals. So this does the same thing as the previous line. It assigns a value to a variable. And I'm going to revert this so you can use any of those two syntax alternatives. And let's clean all this up. And now let's say I want to define all these values in a list. So instead of having them one by one like this, I want to have a list that contains all those items. And then I want to print out the entire list instead of printing out every single item, especially if I have hundreds of them, just in one print statement. And that is another very important data type in programming languages, which is lists or arrays. They're called differently in different programming languages. In Go specifically, we have arrays and slices. And they allow us to define a list of items and to also reference it as a single variable. So it's actually very simple. So I have the same variable declaration syntax, and let's call this task items. And the way we define a value for such a list in Go is using square brackets. Then we have a data type. So we are telling Go program, this is going to be a list of strings, or this is going to be a list of numbers. In our case, we have a list of strings as values. So we're going to say string, and here come the actual values. And let's copy this. The second one, the third one. And as you see, GoLand is actually giving me a suggestion automatically, intelligently suggestion to use the third one. And I'm just going to click on tab. And there you go. So I have all my 3 items, task items in this list. And this declaration here, this thing is actually called a slice in Go programming language. And if I remove this and use task items, so I'm only printing the task items, you see that GoLand is highlighting with a red line, which usually means there's something wrong with your program and you need to fix it. And in this case, it is telling us about an unused variable. So let's see what happens when we run our application with a red warning signs. It fails because it shows those variables are not used. So I'll teach you one additional concept in Go, which is a concept of comments. And this is one of the important use cases of comments. If I don't want to remove this code, but I also don't want it to be executed because my program is failing when these lines are getting executed, I can simply tell Go specifically, ignore these lines, do not execute them. I want to have them in my code, but they're not for execution. And that's where comments come in handy. And comments have their own syntax because Go needs to differentiate. This is a code, this is a comment. And very simply, it's // 2 times. And this line of code now, as you see, it's grayed out as well. So you see it is a comment for you as well. And Go knows it is a comment. So now if I execute this, those lines will be ignored. And we have our list printed out in one line, basically. So let's do one more thing now, which you probably already thought about. Let's comment this in again. And since we already have those values defined and referenced as variables, let's use the variable name instead of the actual string. And this shows you that those variables can be used in any single situation as a representation of the value. So whether it's in a print statement or in a slice like this, variable name can always be used in place of an actual value that it's referencing. So now let's print again. We should get the same result. And I mentioned that Go has slices and arrays, and this is a definition of slice. Now you're probably asking yourself, so what is an array? Very simply, if I want to limit the number of items by default, if I want to tell Go, this is a list, but it can only have maximum 20 items, and that's it, this is going to be an array. So array is with a fixed size, slice is with a variable or dynamic size, so we can expand to as many items as you want. So for example, if I put 2 here, you see, before I even execute, GoLand is telling me, hey, you have a fixed size array with 2 items maximum allowed, and you have 3 items. So this is not going to work. We can see, when we execute, it is telling us that our array doesn't have any more place for the 3rd item. And that's basically the difference. Very simple differentiation between array and slice. And again, the example that I gave before is if we want to limit every group to maximum 20 items, we can use that, for example, right here. Awesome. And same as with variables, we also have the alternative syntax for slice or array declaration, which is same with colon and equals. But let's keep it consistent for now. And let's make one small improvement here, which is before this whole thing is printed, I want to print out tasks right here in front of it. So in this line, in this print line statement, I want to have a string that says tasks. So here I can write tasks, colon, and if I separate them by comma, Golang will basically print this on one line. Let's see that. And there you go. We have tasks, colon, which is a string that we're using. And as you see, it even adds the space between those instead of us explicitly having to add a space character. And then it prints out whatever the value is of all those task items. And that's basically how you can use string and variable reference in the same print statement. Awesome. Now you obviously noticed that we have this one long line of tasks instead of what we had before, which was a nice list of to-dos on separate lines, which looked much cleaner, and we could see exactly this is one item, this is second item. Here we just have everything on one line. There's no comma separation, nothing. So that's what we want to fix next. Okay, so we want to print out those elements one by one on new line instead of just one endless string chain. So the question is now, how do we get each element of a slice or an array separately to do something with it? Either print it out, maybe add some additional information, whatever it is. So basically get each item one by one and then print it out, for example. That's where a concept of loops come in. And this is a concept in every single programming language where we loop through a list of values, we iterate through the list and do something with each specific value one at a time. That's the concept of loops. And the most common type of loop, which you can see in every single programming language, is what's called for loops. And that's what Golang has as well. So It's actually a super simple concept, and this is how it works. So right here, instead of printing out everything at once, we want to print out each item from the list separately. So it goes like this. For, which is a keyword for loop. So logic is for each item in the task items list, we want to do something specific. In our case, we want to print them out. Now this is Golang specific. In for loops, we actually get 2 values instead of just 1. One is the value itself. So we have a slice or an array, and we have the items. So each item has a value, but we also get a second piece of information, which is the index of that item. So this is the first item, this is the second item, this is the third item. So we get that order basically as well, whether it's the first one, second one, and so on. And in programming language, that order is called an index. So we get index and the individual task. We get both items. And as you see again, GoLand is very conveniently suggesting us the rest of the syntax, but I'm actually going to type it out because I want you to follow each detail here. So colon and equals, and remember this from an alternative syntax of variables. So that's how it works. And then we have another keyword of for loops, which is range. And this is the list or range that we want to iterate through. And that's going to be our task items. And then we have a block of code. So I'm going to make this disappear so we can focus on this one. So basically you can read this as an English sentence. We're saying for every item in this range called task items, give me the task and its index. And right here, I'm going to do something with it. In our case, we want to print it out, one task after another. So again, from this list, from this range, we're getting each item separately with its index, and we can do something with it. And because it's a loop, it goes through this list one by one. And we have multiple iterations until it goes through all the items in the list. So it starts by iterating, and it gets the first item. We print it out. Then it goes to the next iteration to get the second item. Then it goes to the next iteration to get the third item. Goes to the next iteration and it says, hey, it's an end of the range. There's no more values inside. So it ends the loop. So that's basically how it works in the background. And as you notice here, we have this red underline. Let's say we only want to print this task, but we don't need to use the index. So we're still getting it. And if we don't use it, our program will not run because we have an unused variable reference. So if I try to execute, here again, you see index variable is defined, but it's not used. So 2 things to understand here. First of all, in a for loop specifically, there are cases where you only need the value of the item of the list. You don't need the index. In which case, you can conveniently ignore that index by just saying underline character, which tells Go, we don't care about the index. You can return it, but we're just going to ignore it. So do not crash our program during execution. Just let it run. So we're explicitly saying we don't need index with this underline character. And the second thing to understand is both of them are variables. So just like we have an actual value that is being referenced by a variable, in a for loop, every item is assigned, so to say, to a temporary variable. So the value of task on the first iteration is going to be this one right here. Then on the second iteration, the value of task is going to be the second value of the list, and so on. And that's another use case of variables that you can also use it to store some values temporarily when you don't actually have the actual value because it changes on every single iteration, right? So now if I print it out, let's see what happens. And there you go. We have list of my to-dos, and then we have each item on a new line printed one by one. So we can remove this, and let's add something interesting here. Let's say we also want to add a number to the task, just like we did at the very beginning, to have 1, watch Go crash course, 2, watch full course, 3, and so on. So we want to have the number also in front of it, but we wanted to have it dynamically. Because as you saw before, if we put those items into different groups, obviously that number will be different, right? So we want that index to be always dynamic instead of us hard coding that 1, 2, 3, right? And that's where we have the index. So let's bring back our index variable and let's use it to print out the number before the task. And we want that number to be right in front of it. So we want index and task. Let's actually print it out and let's see what comes out, okay? And there you go. We have something interesting, which is our numbers start with 0. And that's another important concept of index in arrays and lists in any programming language. It works the same everywhere. Not Go specific is that index starts with 0, not 1. So this is index 0, index 1, index 2. And then we can translate that to the numbers that are common for us humans, because you never start counting something from 0, right? And that's where it's important to be able to get each item of the list right here so we can do anything with it. In this case, we're just printing it out. But the important concept is that we can actually do much more. So this entire block of code, we can use it to transform the value, to add prefix to it, to add commas, to decorate the string in any way that we want. So this is kind of our playground, and we can change it as we want in a flexible way. That's what programming and coding allows us to do. So what I want to do is I want to have here a list starting with 1 instead of 0. And then after that, I want to have a dot. So that's how I want everything to be printed out. So how I'm going to do that? First of all, I'm going to say print out index plus 1 instead of the index itself. That's it. So it's going to add 1 to the index and print out the result. Let's run again. There you go. Very easy fix. Now I want to also have a dot here. I'm going to add a string and comma. Remember, in print line, you can have combination of strings and variables and so on. And you can do it in any order, in any combination with multiple such values. So now I have this dot afterwards and then a task. Now let's run it and we're going to see one small problem, which is it actually adds an extra space character here, which is what happens after when we have this comma separation. So there is another print function in Go called printf. So printf, which stands for format. So we can format the value that we have here as a parameter in a more flexible way. So the way it works is that I have a whole string here, which is a formatted string. And the formatted string basically has placeholders for the actual values that you want to print out. And it lets you then add those commas and special characters and dots or whatever in between. So in the printf, what I'm saying is that I want to have a number here, which is represented by %d, that's for number data type, or a decimal, which is going to be the index itself. And then after that, I want to have dot. And after that, I'm going to have a string value, which is going to be the task. And after that, I'm going to have a new line, because now we don't have that ln at the end. So we need to explicitly add like this. Okay, so we're going to have a decimal dot, then some string, and then new line. And now we have to tell printf what those actual values are going to be for decimal and string. And those are going to be index plus 1. So the first value after this comma in printf function corresponds to the first placeholder, and the second value corresponds to the second placeholder. So this will be substituted here and task will be printed here. Let's comment this out and rerun. And there you go. So we have index plus 1 for a decimal, then it adds dot here, then has a space. Remember, this is a string. Everything within the quotes is a string, including space character. We have a dot character, we have a space character, then we have a placeholder for string, and then we have a new line character. This value corresponds to this one, and this value corresponds to this one. If we had a third one, then we would have third value that corresponds to the third placeholder. And now we can do any other change here. Let's say instead of a dot, we want a colon here. Let's rerun. There you go. And that's the use case of loops, which is when you have a list and you want to do something with each individual item of the list, to print it out or to save it somewhere, to add some adjustments and save it back in the list, whatever it is, you can use loop for that and do whatever you want with every single value in the list, which is one of the common things that you're going to be doing in programming. So this is a very important concept. And also see how clean the code actually is. We have one definition of a list, and we have 3 lines of code that print out everything in the list. Now, let's go back to thinking about an actual TodoList application where we have this logic of printing out a list of items. And let's say this is a logic that we need in multiple places of our program. So for example, we have a complete list view where we want to print all the items, but we also have these separate groups that you create to kind of group together similar types of tasks, and you want to be able to show all the items within a specific group. You may also want to be able to print all the items for today or for next Wednesday. So the same exact logic is needed in 100 different places in our application. Now, does that use case sound familiar? Where you have something that you need to use in multiple places throughout your application code. It's the same concept as with variables, right? But here, instead of having a value like a string or number, we have the entire logic that needs to repeat. So let's say these 4 lines of code is the logic that we want to use in 100 different places. Do we want to copy paste and write the same 4 lines of code in all those places? Imagine if this was 20 lines of code. Do we want to copy paste 20 lines of code in multiple places of our application for every single logic? That's going to be, first of all, a lot of code. Second of all, whenever we change something in that logic, even a small thing, then we need to go and update all those instances of the same logic. It just doesn't make sense, right? It's going to make your code completely unmanageable. And that's where the concept of functions come in. So basically think about function like a variable for a block of code. So instead of saving a string, giving it a name, and then referencing that string value with the name, we save the entire block of code with a name, and whenever we need this block of code, we just reference it with that one single reference name. So we avoid code duplication and make our lives easier. So very simple concept actually, and one of the most important ones, because as a programmer, you will be writing functions and using them all the time. And if I scroll up here, do you see this line that says func main? That stands for function. So we actually already have a function called main, and this is a special function that Go application expects to find in our code, because that's where it knows where the application starts, the entry point of the application is. So just like we have this main function, we can create our own functions with whatever arbitrary name we want, just like with variables, and we can assign an entire block of code to that function. So let's do that right here. So on the same level as the main function, we're going to create our own function, and let's call this print tasks. And the same syntax, we have brackets and we have curly braces for defining the block of code. And I'm actually going to take this whole thing, these 4 lines of code, and I'm going to paste it in here. And this is going to create a function called print tasks. So we have an arbitrary name that describes what this block of code is doing, which is much easier to read and have an overview than trying to understand or remember what this line of code does. So we're giving it a descriptive name. Now, as you see, we have a couple of issues here that are highlighted as red, which means we need to fix something. So what is happening here? And GoLand, again, is helping us understand. It basically says, I don't know this task items variable. Where is it defined? And here it also says, I have a variable task items which is not used. So basically, there are two important concepts that we're going to learn by fixing those two issues. First of all, you may be asking, but we have defined this variable here. Why doesn't it recognize it? It was working fine here. Well, that's the concept of variable scopes. This variable is only visible within the main function, but it's not visible outside. And since the printtasks function is outside of the main function, it doesn't know anything about whatever variables are defined here. So for example, if I wanted to use this variable, it will not know what it is because this block of code does not have visibility into any other functions outside of it. However, there is a way to define variables, to declare variables, to be visible for every single function in your Go application file. So if I copy this whole thing and write outside all the functions on the same level as this import statement and the functions, define them, you see? Now the issue is fixed because now these variables are what's called global variable instead of function scoped variables. So instead of just being visible within one single function where it's defined, it's now visible for all the functions. So that's one important concept. And the second important concept is, you see this function name is gray. And also, let's see what happens if I execute this application now. You see, this line was printed, welcome to our TodoList app, but nothing else happened. So the list of to-dos and the tasks themselves are not printed. So what happened here? We defined the function, we have the same logic, why is it not executing anything? Well, the thing is, just like with variables, we have two parts. We create variable or a function, and then we use that variable or a function. So now we are creating a function, but we're not using it anywhere. And in programming, using a function is called calling a function. So we're not calling any of this logic and executing any of these lines of code in our application. And that's why it's also gray. So the editor is telling us print task is not referenced anywhere. And the way to use a function is the function name and the brackets. This became blue. And in the main function, we are executing print tasks function. If I save this, rerun, there you go. Go found the main function. It said, okay, this is the first line. This is where I need to start executing the program. It saw the first line of code executed. It saw the second line of code, which is a reference to a block of code with other lines of code. And it basically executed whatever this is referencing, line by line. And that's how we got this result. And since we have those global variables, Go also executed all these lines of code, declaring all the variables and then creating this task items slice before executing the main function. Now, maybe you are thinking, so what is the purpose of these empty brackets? Like, they're empty. Why are we using them? And also, since this is also a function, we also have brackets here, but here we have actually something inside the brackets. So why is it empty here and during the execution, and why is it not empty here, for example, in other functions? And that's another concept of function parameters. So let's say we don't want those variables to be global, meaning we don't want these variables to be and values to be accessible to every single function in our application. We want them to be scoped and only expose it to specific functions that we want. So we're gonna bring them back into our main function, which will mean we're gonna have the same issue as before. the task items is not visible for this function. So how do we make it visible explicitly? Well, we can what's called pass specific values or specific information to a function when we're calling or executing that function. And that's where parameters of a function come in. So right here, we can say we want to get a list of tasks as a parameter so that we can print it out in a loop. So first, in the function definition, where we're creating the function, we're going to tell Go, this is a function that is expecting a parameter, which is a list of tasks. So task items, that's going to be the name. And this should be a list of strings. So it's basically expecting a slice of strings as a parameter, and we're calling it task items. And it will then go through that list of items and print them one by one. Now, as soon as we edit this parameter here, this is complaining, saying this function is expecting parameters, but we're not giving it one. We're not passing in that parameter. So to pass a parameter to a function is very simple. We just specify it inside those brackets. So that's what the brackets are used for. If we don't have any parameters, they just stay empty. If we have parameters, we specify it in there. And we can actually add multiple parameters. Let's say if we had another variable here, like max items, for example, and we wanted to pass that in the function as well, we can define another parameter here. And by the way, the names of the parameters that you specify for your function can be whatever you want, arbitrary. It doesn't have to be the same as the variable that you're passing. So I can say item limit here, and we're saying this should be a number. And the data type of the whole numbers in programming is called int or integer. And now we can do max items. And we can then use that variable inside the function as well. So you can pass as many parameters as you want to a function. However, if you want your code to be clean, you should limit the number of parameters to a function. If you have a function with 20 parameters, that's definitely not a good coding practice. And also, functions should usually be capsules of one specific logic. So one function should be doing one thing instead of 20 different things. And that's basically a foundation of clean code or clean coding practices. And there you go. Now we have variables defined within main function scope. They're not global. And we're explicitly passing them or giving this information to printTasks function so that it can use it inside its logic. And now, whenever we need these 4 lines of code, this logic, and let's say we have hundreds of Go files here, we can simply take printTasks, pass the list of items, and reuse this logic multiple times. Again, let's execute to make sure everything works, and there you go. Okay, now let's actually make our program a little bit more interesting, and let's create another function for adding the tasks. Because we have predefined tasks, we're defining 3 items as soon as the program starts, but we also want to be able to add tasks dynamically in our program, right? Because how else can you use a to-do list app if you can't add additional tasks to it? So let's create a function called add task. And here we're going to have a logic that basically takes the task items, so the same task items list that we have here, and basically add a new task to it. So that means we want to pass parameters to this function that has a list of tasks or task items and the new task to be added to that list, right? So just like we do here, we're going to pass the task items and new task. And this is going to be a string type. And here we're going to learn a very, very simple syntax of how to add a new item to an existing slice, which is very simple. We have a function called append, and this function takes the list, whatever list that is, a slice basically, and a new item to add to that list. And it returns an updated list with a new item. And that's why we have this red underline, because it says, let's see, it's not used, meaning the value that this returns, which is again an updated list with a new item, we need to assign it back to a variable. So let's call this updated task items. And there you go. So we just added a new task to the existing task items list. And we can again iterate. We can write a for loop here to go through the list and print out every task one at a time. Or we actually have that logic already in this function, right? So we can just reuse that loop functionality to print all the items in a list by calling it here and passing it a list of items, obviously. You see? So we created an additional function, and already here we needed the same exact logic that we have defined in this function. So instead of repeating and writing this logic again, we can just reference the function very easily, pass the parameter, and that's it. Now this is just the function definition. We are not using it or calling it yet. And that happens back in the main function. So here we are printing out the tasks that are defined here. And after that, we're gonna add a new task. And let's see, our add task function requires the task items and a new task that we want to add, which is a string. And let's go for a run. That's our next to do, which will add that new item to the list and will also print the updated list. And let's add a new line between those two with just an empty line. And let's execute our program and see what happens. Okay, so this was print tasks execution with those three items that we have defined at the beginning. And then we add a new task using add task function, which then prints the updated list. Now here is something interesting that we're gonna see now. Let's go back to our main function and let's see what happens. Let's add a new line. And what happens if I print the task items again, right? So we are printing this out, we're passing it to add a new item to it, we're printing it out. So what do you think happens to task items list? Let's execute the program and see. Okay, so we have these three items, then we have add task that adds another task and prints those items. But back in the main, when we print task items slice elements, we don't have that additional value. And that is also an important part of variable concept, that whatever happens here is only affecting the variables within add task function. That goes back to the scope of variables. So these task items that we're passing to add task is a variable within add task. So these are also called local variables within the function. So this variable here, these parameters, these are all local variables of the add task function. So whatever we do here does not actually affect anything in the main function, which is good because our functions do something in isolation and they don't affect some things outside of the function, giving us some unexpected results. So this is actually a good thing. But in this case, we explicitly want to modify and change the task items, right? This is the main list basically that the main function has, that it passes on as parameter to all the functions. So we actually want the new item to be added to this variable, to this list, instead of just being done once here and then have no effect, right? So how can we do that? And that brings us to another important concept of functions, which is returning value from function execution, which is returning the result of add task function execution back in the main function. So whatever this does, basically take that value and give it back to the main where the execution happened. So basically, just like main function passes some value to the function as an input, the function can then pass back the value as an output or result of the logic execution. So we can give back, here is an updated list after adding this new item. And that's also very easy to do. So instead of printing out this variable, this updated task items list, at the end, we're gonna return that updated task items list back to the main function. And whenever we are returning a value from a function, we also need to specify it in the function definition. We need to tell Go, this is a function that takes 2 parameters and returns a value. And we do that right here. And this is, by the way, specific to Golang. Some programming languages, for example, do not need to define what you are returning from a function. So this is Go specific syntax. So basically it's the same as with parameters. We're defining what parameters of what types are we passing, how many of them, and here we're defining what result of what type are we returning from the function back to the main. And we only need the data type, not the name of the variable, by the way. So we're returning a slice of strings, and in Go, you can return multiple values, again, specific to Golang. So you can return multiple values. However, if you're returning just one, then you actually don't need the parentheses. That's what this warning is saying. So we can remove that. So this is defining what input or what parameters the function is getting. This defines what output or result the function is giving back. So now, let's make a space a little bit. Right here, this line of code actually returns a new value that we can assign back to the variable. So what we can do is we can take our existing list and we can say, take the updated list and set the value of that updated list to the original list. So we are overriding basically the original list with a new updated list value. So again, this function is getting the original list, adding an item to it, and then returning that updated list. And then we're saving that updated list as a value of the task items. And now when we print the task items again, this should actually be the updated list instead of the original list. So let's run our program. And let's see. So this was the original list, and this is the updated list. So right here, you can say updated list. So if we run our program again, let's see, this is the original list, and this is the updated list. And now we can do this multiple times. We can add another item to the list. Let's say practice coding in Go. And let's see what happens. So we are adding one item here, we are adding another item here, and then we are printing out an updated list. So let's run it. And there you go. Item 4, item 5, edit. Awesome. Now, as a final part of our project, let's make this application usable from outside users. Because till now, we have been defining the tasks and we have been adding the tasks. So there's no user who is interacting with our program. Everything is hard-coded into the code. So let's say we want to make this available to someone who can add their own tasks and then print out their own to-do list themselves. right? To make the program actually usable for the end users. And even though this is a crash course, I wanted to include that to actually show you how the real end application looks like when it's usable by external users. And for that, we're gonna build a very simple web API. So basically an interface, a web interface that users can interact with the application using HTTP endpoints. If it sounds complex for you, don't worry. We're gonna demo it in a very simple way. But if you want to better understand HTTP, HTTP server, and client before jumping right in the demo, we actually decided to make one lecture of our IT Beginners course temporarily public, where HTTP URLs and IP addresses is explained in a detailed but very simple way. We will leave the link to this lecture temporarily in the video description. And if you don't know our popular IT Beginners course, this is basically a mini bootcamp to understand the whole software development lifecycle, from programming to writing automated tests to spinning up virtual server environments to packaging and deploying the applications that you programmed to these deployment environments. So whether you are a junior software developer or tester or product owner who is involved in software development process, it basically will give you that big picture understanding of the whole process and fill any knowledge gaps that you might have, and just give you that important technical, fundamental engineering knowledge you will need at work. So again, if you think it's useful for you, definitely check it out. And now let's go back to our demo. Okay, first, let's create a boilerplate code, which is the most basic code to get something to work for HTTP API, so that users can use our application using HTTP clients or web clients. So first I'm going to clean up all this. And you can actually back it up or save it somewhere if you want to. But I'm going to remove all this code in main function. And right here, I'm going to start what's called a local server to make our application available to end users at HTTP endpoint. So just like we imported this FMT package, there is a package called HTTP, which has a function called listen and serve. And as soon as I hit enter, GoLand automatically imports this HTTP package in our Go file to make it available. And here we have two parameters that we're passing to this function. The first one is address, as you see, and that is where the application will be running, or on which port the application will be running. And as you see, our application will start on localhost, which is my local computer, so nobody else in the world will have it available. Just me on my local computer will be able to run it. That's what localhost is. And my machine, my computer, has multiple addresses where different programs can run and listen for any requests. And one of those addresses is 8080, which is kind of a standard for web applications. And that's the first parameter. And the second parameter is basically if something goes wrong, and if we mouse over here, we're going to see this is the address and this is a handler, which is what happens if the application cannot start, but we're going to ignore it using nil, which is basically like an empty value. So we're saying ignore if something happens. And this actually starts a local server that will make application available on this port. Let's actually run it and see how it looks like, because it may sound a little bit abstract for you right now. And as you see, we ran the application, it printed out the first line, and now it's waiting. So unlike before, when we executed our Go application before, it's still running and it's blinking the mouse because it's waiting for something to happen. So the application started, the local server started, and the application is available on this port and it's still running. I can explicitly stop the application, but it doesn't stop by itself. So now let's try one interesting thing. Going to our browser and type in localhost 8080. Let's see what happens. It says page not found. However, the fact that we actually got something here means that there's an application available at this address which return a specific message, page not found. Because if I did the same on localhost, I don't know, 8085, where there's nothing running, I would get this message. So instead, I'm getting a response from the server that we just started. Cool. Now, let's actually return some message that we see here from our application. So right here, we're gonna make space, and we're gonna write what's called a handler. So whenever user tries to access our application, it handles that user request and sends back some kind of response. So we have a request from the user and we're sending a corresponding response back. So this HTTP package has a handle function, and I'm gonna type this out actually. And this takes two parameters. The first one is the URL. So this is a URL, basically. This is a root URL. We can also have hello, go, some additional string, and so on. So right now we're saying whenever this specific URL, so the root URL, is requested by the user, we want to execute some logic that returns user a response. And we're gonna put that logic in a function, and let's call this hello user. And if I mouse over here, you have this create function hello user. So let's click on this and let's see what happens. You see, it automatically created a function handler for our HTTP application. And you can hit tab on all places to accept, basically. So let's see what happened here. It created a function called hello user, and it automatically added these parameters. So what are these? As I said, we are getting a request from a user, and we're sending a response to the user. So we're getting the response automatically. So HTTP, this package here, manages everything in the background, starting the server, allowing requests to come in. And as you see, this is the variable name. This is the data type. So a request comes in, and it also gives us so-called response writer to write a response back to the user. So now we're going to define a greeting message, and we're going to say, hello, user, welcome to our TodoList application. And we can actually remove it from here. And now we want to send this greeting back to the user. And as you see, we have again suggestion from GoLand that is offering us another function from FMT format, which is fprintf or fprintline. We can use either, which is a specific function that can take this response writer from HTTP package as an input, and using that response writer, send any value back to the user as a response. Okay, and we're seeing these warnings here because it's warning us about unhandled errors. So basically, anytime something happens or something fails in this execution, what we're going to do about it. Right now, we're just ignoring it. We're not going to do anything about it. We're just letting the application crash, which is fine for us for now. Okay, so again, let's see what's happening. We are registering a handler function whenever someone accesses our application. This is called a root URL. We are executing this specific logic, which is sending a greeting back to the user. So now we're gonna restart our application, or we can just stop it and start it again. And let's go back to browser. And now let's see if I refresh, we get our message from the Go application. And now let's do one more thing to really understand what this value is. Let's put here hello Go, like this, and let's restart. And now if I refresh this, I again get page not found. However, if I put hello Go here, you see, that's where I'm getting the message. So this basically defines which URL of the application is this logic gonna execute. And whatever that URL is, basically I provide it here in the browser. So every such URL can have its own handler. So for example, let's say this is the root one, so basically a general one that welcomes the user. And let's say this is show tasks. So I'm going to have show tasks function here. And again, let's use Golang to create the function. So here I'm going to bring back my task items, and let's actually define them as global variables so that I can use them right here. And we're going to send back as a response to the user the list of task items that I have. This is a little bit more complex, so let's go through this step by step. So let's try the same logic as before by taking this print line instead of greeting. Let's try sending back the items. Let's see what happens. And again, we've defined that on show tasks, this function logic will execute, sending back the task items. So let's see what happens. So this is where we get the welcome message, and let's see what happens if I do show tasks. And as you see, we get this slice with all my to-do list items inside, printed out like this. And to display them as individual items, we can use the loop. We don't care about the index, we just need the task, let's say, and have the range of task items. And inside, we want to print one task after the other. And again, let's see what happens. Let's go back, refresh, and there you go. And we can delete both of these functions because everything now is happening via the HTTP endpoints and their function handlers. And we just made our application into an HTTP program that any HTTP client can actually talk to. So browser is actually just one of the HTTP clients that is sending HTTP requests to a program, but there are other ones as well. For example, we have a CLI HTTP client called curl. So for example, if I go to terminal and if I do curl localhost 8080, let's see what we get. You see the welcome message. And we can leave out the slash, obviously, it's just a default for root. And now if I do show tasks here, we're gonna get the list of task items. So curl is a command line HTTP client, while browser is a UI-based HTTP client. And the GoLand IDE actually has its built-in HTTP client. And you see this globe icon here, and if I click on it, we have this request generator, and if I click on it, we have get localhost. So as you see, this is a built-in program of the editor, and if I run this, it shows the welcome message. I can also run show tasks instead. Let's run it, and there you go, we get the list of arguments here. So I wanted to show you, just to highlight that our application is now an HTTP backend application that any HTTP client can connect to that is running on our local machine or local host and interact with it. Instead of before, where we were just executing the code within the editor and that was it. And To make sure that you are not confused, this is the execution of the HTTP client request, and this is our application. So just click on it to go back to the app. Now, I hope you learned a lot in this Go crash course. Thanks for watching and see you in the next video.